In this video, we're going to go over L'Hopital's rule. Knowing about L'Hopital's rule can make certain problems on our final exam and also on the AP exam a little bit easier. It's not required for either exam, but if you have limits that look like this, where we've got the limit and we've got a function on top and a function on bottom, and if you plug in a and you either get 0 over 0 or infinity over infinity, it turns out that the limit of the original equals the limit of the derivative of the top over the derivative of the bottom. But it's very important that this situation is true. All right, so let's take an example problem. Now, when we look at this particular example, hopefully you recognize immediately that you know how to do this without L'Hopital. So let's just quick do it without. You should look at this and feel a burning desire to factor. So x plus 3, x minus 3, all over x minus 3. Those cancel. We can plug in 3. Our limit is 6. Now, if we had started this by putting in 3, which is always a good idea to do, we would have seen that 3 squared minus 9 gives us 0 on top, and 3 minus 3 gives us 0 on bottom. This means it's a candidate for L'Hopital. By the way, L'Hopital is a French name, and that's why it's not pronounced quite the way you might think Le Hospital. It's actually L'Hopital. All right, so since we got 0 over 0, that means that we can rewrite this, and oftentimes we'll put an equal sign with an H over it to indicate we're using L'Hopital. We're going to rewrite it by taking the derivative of the top. The derivative of x squared minus 9 is 2x, and the derivative of x minus 3 is 1. We plug in 3 and we get 6, the same answer we had up here. All right, so let's go ahead and take a look at this problem. So here we've got a picture here, and we've got the limit as x approaches 6 of f of x over g of x. Our first thing should be to see if we can just simply plug in 6. So we go look at this graph, and let's see, f of 6 is right here, it's 0. And g of 6 also is right here, and it is 0 as well. And so it is a candidate for L'Hopital. That means that it is going to equal the limit as x approaches 6 of f prime of x over g prime of x. And so we would do f prime at 6 over g prime at 6. And if we're looking at the derivative of f, so here's f, its tangent line is this one, so that means it would equal negative 2/3 over, and g prime at x is going to have this tangent line here. Its slope is right here, 1, and so our answer would be negative 2/3. All right, let's try another one. So we've got the same idea here, where we've got the limit as x approaches a, and if we plug in a, f of a and g of a, we'll notice that at a, the y values are both 0. So we can go ahead and say, well, that's going to be the same as the limit as x approaches a of f prime of x over g prime of x. Well, we should notice that right here, our tangent line is going to be this horizontal line for both, which means our slope is 0 in both cases. So we get 0 over 0. Well, what do we do if we still have 0 over 0? Well, then we do L'Hopital again. And we take the limit as x approaches a of f double prime over g double prime. And now when we're looking at the second derivative, we should realize we're dealing with concavity. Now in this case, we don't have a number for that, but we were simply asked for the sign in the original problem. And we know that they're both concave down, which means both second derivatives are negative, which means our limit is positive. Let me write that a little more clearly. And so the answer is that it is positive, so equals a positive. All right, so let's try another one here. So remember, always the first step is to plug in the number. So natural log of 1 over 1 minus 1, we get 0 over 0. It's a candidate. So I now take the derivative, the limit as x approaches 1. The derivative of natural log x is 1 over x. The derivative of x minus 1 is 1, and now I plug in 1. 1 over 1 equals 1. I'm done. Let's try our next one. So I'm going to plug in 3, and when I plug in 3, I get 9 minus 9 over 3 minus 2. Well, that's just 0 over 1. 0 divided by 1 is 0. Done. Notice not a candidate, and I didn't need it. I can figure out 0 over 1. I do want to point out, so let's just point this out, not a candidate, and using L'Hopital would get the wrong answer. Using L'Hopital would get the wrong answer, or get the wrong limit. So let's just do that just to prove it real quick. So if I did the derivative on top, 2x, the derivative on bottom, 1, I plugged in 3, I would get 6. And that is not the limit. The limit is actually just 0. All right, so now here we have one where it's approaching infinity. And when we're approaching infinity, we're going to look to say, okay, well, what does e to the x do as I go to infinity? And it goes to infinity. What does x squared do? And it also approaches infinity. Now, infinity over infinity cannot be made to equal 1. We have to go farther. And since it's infinity over infinity, we can use L'Hopital. So we've got the limit as x approaches infinity. The derivative of e to the x is e to the x. The derivative of x squared is 2x. And when I look at e to the x, I know it's heading to infinity, and I know 2x is heading to infinity, so I'm not much closer, but let's try it again. Limit as x approaches infinity. The derivative of e to the x is e to the x. The derivative of 2x is 2, and now I can see this is going to go to infinity. Now, not every problem with infinity over infinity is going to go to infinity. Let's take a look at this one. So if I plug in 1, I get 0, and I plug in 1 on the bottom, I get 0. It's a candidate. So now I'm going to do L'Hopital. The limit as x approaches 1, derivative on top is 9x to the 8th, derivative on bottom is 3x squared. Now I plug in 1 again, and I get 9 over 3. My limit is 3. All right, we have one last problem to do with you to make sure we're feeling good about L'Hopital. And let's take a look at this one. You'll recall that as I go to infinity, the natural log function, remember it looks like this. There's our natural log graph. It goes to infinity. And cube root of x also goes to infinity. So cube root of x looks a lot like square root of x. It's a function that looks like that as well. So they both go to infinity. So we're going to use L'Hopital. The limit as x approaches infinity. The derivative of natural log x is 1 over x. Derivative of cube root of x, 1/3 x to the negative 2/3. Now in this case, it probably makes a lot of sense now to do some cleanup. I'm not going to use L'Hopital again, but I'm going to do a little algebra to see what happens with 1 over x over the other. So let's take this as 1 over x over 1 over 3x to the 2/3. Limit as x approaches infinity, and I'm going to divide my fractions. So 1 over x times 3x to the 2/3 over 1, and I can reduce this. So now I've got the limit as x approaches infinity, and let's see, I have a 3 on top. Remember, this is x to the 2/3 and x to the 1st, and I have x to the 1/3. And I can see that as x goes to infinity, this is going to go to 0 because x is going to keep getting bigger and bigger and bigger, and 3 over this bigger and bigger number is going to go to 0. So just to walk through this again, we used L'Hopital for the first step, but then we rewrote this x to the negative 2/3 with a positive exponent down here. Then I divided this fraction by the reciprocal of that fraction, and then I took my two fractions and I simplified, subtracting my exponents, knowing I had more x's down here. And remember, when I have x in the denominator here getting bigger and bigger, my fraction goes to 0. All right, that's it for what I have for teaching you about L'Hopital.